Hey, this is Corey Glenn, and I'm going to show a video today of how you could go about making a flexible partial. So a lot of times temporary situations or maybe just a low-cost option to replace some teeth, you're going to need the ability to create some kind of a flipper. So that's obviously something you could have lab made. Many people do prefer the flexible type partials, but we've not really had great options until now to be able to do that for ourselves. So I'm going to show you a solution to that. So this is just a model that I'm scanning. In an ideal world, you would either be just directly scanning the patient in the mouth, or you would take some alginets and then scan those models on a desktop scanner. But since I'm not doing a clinical case, this will suffice. So I'm just going to go around and I want to make sure I get all the extension of anywhere that I would like this partial to sit, and try to get the best and most accurate model possible. And the scanner I'm using here is the Carestream 3600. We have several. This is the one I keep in my office for quick scans of things. So whatever scanner you use, it won't really matter. And basically with the process I'm going to show you, we're going to do a single step in Blue Sky Plan, and well, actually two steps in Blue Sky Plan, and then we're going to jump out, and the rest of this will get done in Meshmixer, which I know some of you cringe right away when I say that, but deal with it. Meshmixer is great if you'll just push through the learning curve. All right, so there is my intraoral scan, and now let's go ahead and export that. Okay, so I've scanned the model and exported it, and so now we are ready to go ahead and bring in the model to do some design in Blue Sky Plan. So we're just going to say model editing and just design in the model editing module. And let's do the alignment. So we'll say this is a dentate model. It's a mandible. Continue to the alignment. And now we just need to orient this. And so this a little clunkier when you have partially dentate models. But as you can see, just 3 quick dots there, and that gets it oriented. This doesn't have to be perfect by any means. All that you're trying to do is orient your model in the same way that this skull is, because this is what Blue Sky sees as up and down and side to side. We're just trying to make the model match that. So now I've finished that, and there's 2 steps that I'm going to do in Blue Sky for this process. And the first is that I'm going to place the teeth. So let's go ahead and add some teeth here and choose whatever library you want. Let's just grab this Bastion de Loge. I need to see what teeth I need. So we need everything behind the canine on this. I'm just going to go back to first molars. And then we just need, well, I take that back. Let's go to second molars and then second molars on the other side. So we're going to add all those teeth, just drop them in. And now you can begin positioning those one by one. Now, one thing that is disadvantageous to doing this model editing is you can't scale all these teeth at once. The place where you can do that is in the denture module. So if I was to go to the denture design panel and chain all of these teeth, now I've got the ability to scale them down and start getting a better idea of how large these need to be. So you could definitely do that one at a time, but just might save you a little time. And when I'm scaling these, I'm really trying to reference these premolars in comparison to these premolars. And that looks like they're pretty darn close, maybe need to be a tiny bit smaller. Great. And then I'm just going to go to manipulate model and pull these things into position. Now, I clearly don't have an opposing model on this because I don't want to mess with that just for sake of the demo. But if you did, you're just going to take a little bit of extra time to make sure that the occlusion is proper, and that you don't have any cusps that are impinging into the opposing model. For this purpose, we're just doing a very quick demo to give you a feel for the overall process. Okay. Now that's obviously not ideal, so pull these guys down, rotate. And I wouldn't worry too much if it's impinging down into the model. We can deal with that later. So as I'm doing this, again, without an opposing model to kind of help dictate things, I'm just trying to think about a plane that goes from tip of the canine to the middle of the retromolar pad, and just trying to put them on an approximate plane with that. Okay, we need to get a bit more arch form to this. We could maybe bow this out ever so slightly. All right, that's looking good. I'm also going to create just the slightest bit of impingement of these teeth into one another. Okay, just because I only want to print these as one piece. I don't want to mess with having individual teeth to deal with when I do the bonding process. And then let's do this other side. So this time I'm going to start with getting the height in the approximate position. Okay, and there we go. Now, there's really not a way in Blue Sky Plan to design this all the way to completion currently. You can do complete dentures and you might do a single tooth partial, but if you're trying to make clasps and things like that, you really can't do it to its entirety in Blue Sky Plan currently. But what you can do is you can do the tooth positions. Okay, so I've got those set. I'm going to go ahead and export those while I'm thinking about it, along with this model. So we've got everything checked, and I'll call this T. Now think about on a partial, if you've got clasps in place, if this was just going to be something that draws on and off of the jaw, then no big deal. We don't really have to do a lot. But if we're going to go the extra step of creating clasps in this design, then there's a few things we need to do. Think back to your old dental school days when you used the survey table and all that kind of stuff, where we would try to identify the undercuts and then pull a clasp around that just engages into that undercut. So I need to generate a model on which I could do that, because right now I would purely be guessing. And you might say, well, with flexible partial, guessing's fine because it'll flex over it. But if we can do it a little more precisely, let's try to. So what I'm going to do here, teeth are chained. I'm going to trick the software and tell it that I'm going to build a denture now. Okay, so I create denture. And if you've used this before, you know that the very first step on this is that you're going to have to indicate a path of draw. So when I'm doing this, I'm trying to think in terms of the path of draw of clasps on these distal teeth, right? This one and this one. And then also you want it to be a reasonable path of draw that's not too difficult to get in, okay? And this is a useful feature. We can control how much of an undercut. So for retention's sake, you do want it to flex over the height of contour and then lock in just a little bit, but you don't want that to be excessive. Otherwise, you make teeth sore and hurt the tissue and all that. So I'm guessing I need to play with this and dial in the fits and everything before I would really tell you to go with this. But for right now, let's just go with a 0.3 undercut. And I want to set the insertion direction from the view I have indicated right now. Okay. And because I might not be able to see as clearly where those undercuts were, I'm going to go ahead and save myself 2 screenshots of where those undercuts are from a lateral view. Then I'm going to spin it over here and look from this side. I'm kind of trying to orient this where I could see the lingual of this and the buccal of this. Okay, so one more screenshot. I don't know that I'm going to need those. I'm just trying to think ahead in case I do, because I don't like backtracking. Okay, so now that we've done that, we've told it, that we want to block out these undercuts, but we're going to allow undercuts up to 0.3 millimeters. So anything that you see brown right here is in excess of 0.3 millimeters. Okay, So with that done, now I'm going to click next. It's going to generate that path of draw model. All right, great. And then I want to export this as well. So file, export data. And this time I only want to do that path of draw model. I call these POD. Okay, so we are done in Blue Sky Plan, and notice that that did not cost us an export of any kind. At this point, I want to go into Meshmixer and open these files up. Okay, so I've got model and teeth and POD, pull in and append to this mesh. Then I'm just going to hide this mesh because this just happened to be a pre-existing case I had open. Okay, so now we can see this. Now, one thing I hadn't considered is that since we did export just the standalone model before it had any undercuts blocked out, and right now that is saved as a single STL with these. If I wanted to separate that, I can just click this one, hit E for expand to all. Okay, these are your hotkeys. Always make notes of those because you can work a lot faster if you use the hotkeys. That selects all this, and then the hotkey for separate is Y. So now this is its own STL. We can turn the teeth off. But one of the things I just realized is that now if I turn on that path of draw model, I don't have to necessarily take those pictures I thought I might need because I can simply see now the areas that have been blocked out. Okay, so when I make this, I want to build it on the model that has excessive undercuts blocked out. Okay, so that in fact is what I'm going to do. Now, one other thing that I mentioned earlier, I told you don't worry a whole lot about if your teeth are impinging into this because we can deal with that later. That is something I'm going to go ahead and do at this step. You could do it later. Doesn't really matter when you do it in the process. But what I'm going to have to do is Boolean subtract this model from these teeth. Okay. If you've used Meshmixer enough, you probably know that Boolean functions work best when you've made models solid. So I'm going to edit and make solid, but the downside is you can lose accuracy. So take it to accurate and the maximum accuracy and increase the mesh density because that's going to reproduce those details better. Now you can do Boolean differences without making solid, but really what it comes down to oftentimes is the meshes can be very dissimilar. If I turn on the wireframe, now you can see how similar these meshes are. This was a little more dense because I wanted all that detail, but that's fine. But sometimes teeth, and especially things like implants and abutments, when they're exported from CAD softwares, they have a really irregular meshes compared to something like this where it's all equal triangles, and that will just throw any kind of Boolean functions for a loop. It won't do it successfully. All right, so I've got those teeth done. Now, when I Boolean subtract this, I'm also thinking about I don't want just a dead zero subtraction because if I do that, then that's going to make my base be perforated through and then I'll be bonding teeth to it. I'd rather my base be fully intact on the bottom. So let's think how we could do that. So I'm going to take the distal of this tooth and then the whole crest of the ridge that these teeth are sitting on. Make sure you don't miss any parts where teeth might be sitting on it. And then same thing over here. All right, so what I'm going to do is go ahead and offset that. So edit, offset. By how much? Well, this is very similar to step, I think, 4 in the denture module in Blue Sky, where you have to create how much of a spacer do you want between teeth and the base, but then also how much base minimal thickness do you want to create. So I'm just going to make a number here. I want to keep 0.5 millimeter of minimum thickness to that base on the ridge before it comes up and now you've got teeth to bond in. So now let's let it refigure. Okay, and you can see if I zoom in here that I've got that 0.5 millimeter spacer. So I'll accept that. And then anytime you do that, it's still going to be orange, the new part you've offset, and you want to separate that off. So again, what's your separate? It's Y is the hotkey. You need to find that up here, edit, separate. And you You see the hotkey is listed. So I'm going to separate that off into its own mesh. Now I can hide this. And so what I want to do is I want to take these teeth and I want to subtract this offset mesh. So Boolean difference. Great. So now you see that I've got enough spacer under there. So these are not going to impinge into anything. I'll accept that. Okay, so now you should see, when I look from the inside of this mesh, I don't see any teeth protruding through anywhere on this. Okay, so now we need to design the base. And we're going to have to do one Boolean function later on to subtract the sockets for these teeth. And we'll deal with that when we come to it. So think about your denture base. What kind of extension do you want it to have? So I want to go from back here, maybe retromolar pad. I'm not going to do this perfect just because I don't want to waste the time. Just for demo, you can get the idea and concept of this just as easily if I do a crappy job. It'll take me less time. Okay. It's going to extend around on the lingual of these teeth. So maybe you want to get a little bit of coverage up on the cingulums of these lower teeth. Maybe you just want to do it like more of a lingual bar. That's up to you. I don't care which way you do it. Now, I'm thinking about these tori here, and if you just made a base that doesn't have undercuts blocked out, it's going to lock into all those. However, remember, I also did allow it up to a 0.3, I think, undercut. And I'm thinking you don't need the lingual extension down here into the mucosa anyway, so I'm going to make it just end where it rests on that tori about so. And then as we go back here, we can maybe lengthen the extension a bit more. Okay, so there's my overall saddles. I do need to color this in. So a lot of ways you could do that. If I go ahead and hit B, that's going to smooth the boundary, but it's also going to create some new face groups so that now I can just double click this. And now all of that's included. And I need to also give a little better contour to this side, and I don't like how thin that extension is. So I'm just going to come over about like this again. Play with this all you want. You can put them anywhere you want. And the beauty of these being printable, this printed resin actually adjusts way easier than the traditional flexible partials that we've all used. So it's really easy to adjust. But man, if you end up adjusting it too much, then you can add back to it with the resin that you're going to have in-house, or you can just print a new one. So I don't really care about messing these up near as much as I would a traditional lab-made flexible partial. All right, that looks good. And I'm thinking about on the distal here, being able to wrap around, have a good plane that it can sit against on this tooth. Need to create that on this tooth as well. Maybe a little too tall up here. There we go. And then I'm thinking about clasps. So here, to create some clasps, I'm going to drop into these undercut areas a bit more. So remember, you can put these wherever you would like. So I'm going to try to follow closer to the gums with these. And maybe into that proximal surface. And remember, I am engaging undercuts, but only up to 0.3. So if there's an undercut that's beyond that, it's just going to get blocked out. So I'm not worried about that since we took the time to create that path of draw model in the denture module. All right, do whatever kind of clasp design you want here. Again, I've not done enough of these clinically of designing on my own to really give you tons of feedback on the ideal parameters. That's for you to figure out after you do a few of these, because I'm not seeing patients anymore. All right, that looks pretty good. And now I'm going to come around and do the same thing on this canine. So probably won't have that clasp reach into right there. Now aesthetically, this is not going to really show, so less important than maybe it would be on the maxillary. But I do want to keep those off the gingiva, because I find those flexible partial clasps, if they're on the gingiva, they just will eat the patient alive. They're really uncomfortable. All right, that's good enough for demo purposes, right? So one more time, smooth the boundary. Anytime I smooth, it's always wise to go ahead and do optimize boundary and then smooth boundary. But I use the hotkeys, that's O and then B. So I can just hit O, that's optimized, B, now it's smooth. And then enter, and now we have this all as its own individual face group. This is going to be my denture base. Okay. Now this, printing, we can't reproduce detail less than 50, 100 microns, whatever we're printing at. So I would at least want to create a little bit of an offset spacer and not go dead zero to the teeth, because it's going to end up fitting a little tight. In my experience, like a surgical guide, we usually do a 0.2 offset between the surface of the tissue or teeth and the guide. Let's go middle ground here. We want a little more intimate fit with this and for it to snap in. So I'm going to take all this surface, I'm double clicking that face group, and let's see a few little areas I want to smooth back up again. So just give it a good once over and make sure you like all of your contours. Again, this is easily adjusted. I might be nitpicking, but so be it. Once again, B, smooth it, accept that. Now, with all that selected, what I'm now going to do is go up here to edit and offset. Again, just like we did earlier with the tissue surface, only this time we're actually creating the real denture base. This is your flexible denture base. So what kind of offset do you want for that? I'm going to go with 0.15. How about? Now it's going to default to whatever the last offset that I did, which was 0.5 when we were creating the spacer for the teeth. So I'll have to let it figure and then come back and correct this. So now I'm going to change that 0.15, enter, let it reconfigure, and there we have it. So I'll accept that, and it should still have a great smooth boundary. If it doesn't, hit B again, let it smooth itself out. Now, while this is selected again, you could go to edit, separate, or you could just punch Y. And now this is its own STL, which is what I want because I'm creating an individual denture base at this point. So now what I've got to do is, give some thickness to this. Right now, I think you'd agree this is not a printable shape. We need to generate a printable shape. Now, one of the easiest ways, in my opinion, to do that is come back in here again and just edit. Some people will try to do extrude. Let me show you why I don't generally do extrude. Is because it's going to all want to go in one direction. Like if I do this, that doesn't work. If I change to normal, then it gets really confused because now it's just trying to expand it out in all directions. And really, I'm looking at that. That's not terrible. We could make that work. But I think the easier way to do this and the more accurate way is to once again go into edit, offset it. And now this time think about how much thickness would you like to have to that partial. And I would think in terms of minimal thickness. So at its thinnest point, I would probably like this thing to be 2 millimeters thick. Okay, so we've got that now. And I'm going to accept that. Now, don't go ahead and join these. So at the end, when we're ready to, we're basically going to take this surface right here, and it's going to have to be flipped inside out. So if I go to edit, flip normals, that's what we want. The mesh facing out, mesh facing in, and then we're eventually going to click the borders and hit J to join those. But I don't want to do that yet. And the reason why is I need to do some festooning on this. So let me create a little hypothetical for you here. If I turn these teeth back on, I currently need to festoon this gingiva up. And let's just say that I use the sculpt tools right here and I get, let's say, the inflate, and start inflating this up. The downside to doing that while these are still joined as one mesh, and I don't know if it actually happened there, but it inevitably would, is your tool is going to bleed through and work on the underneath surface, which we need that to remain completely unchanged. So I'm going to undo that, so Control Z. Instead, what I want to do is click this mesh, because right now there are two meshes in one STL. I'm going to click E to expand to all the connected, which doesn't select the inside, and Y. So now this is its own mesh. I can work on this one all that I want without worry of distorting the tissue intaglio fit. So some of the things I would do is in offsetting, you're going to get some weird contours like that. So I might come in and use some smooth tools and smooth those up. I'll hide the teeth right now. So smoothing those up, I'm going to go along most of the edges here, because one of the things you will see is by virtue of offsetting, it gets taller outward in every direction, and we don't necessarily want that. We kind of want a flat contour across. So using the shrink smooth tool can bring some of that back down to where you're going to not be so high. If later on, though, it needs to, we'll just cut that down manually. Okay. I'm going to go through here. I'm thinking too from a tongue feel perspective that this is all going to be super annoying to a patient. So I'm going to increase the strength and really smooth this out. I want that to be glossy smooth for the patient's tongue to be sitting against. Probably same through here, because I want intimate fit internally, but not externally. Externally, I want this to feel really comfortable to the patient. Okay, I could keep, if that extension is problematic for me, I could just keep on using smooth, which is going to knock it back gradually. If you want to do that, I'm not going to spend a lot of time for it. Smooth this. Okay, the clasps, they got grown in every direction, so I'm going to knock them back a little bit, shrink them down. There's not necessarily a right or wrong to this. You can always do it. If you don't like something, just use your tools to tweak it, add to it, subtract from it, whatever you need to do. But now we're looking like something that's going to be a little better, okay? And just to give you a reference of what that looks like. Now, I don't want to do the joining yet. This is the step at which I need to festoon. All right, so notice my teeth are not impinging through into the internal, because that's only offset by 0.5, whereas what I subtracted from the teeth was this internal is 0.15. The teeth I subtracted 0.5 from, so they should be in that sweet spot where they're falling right in the middle between these. That's perfect. So without altering the shape of this, we want to now think in terms of festooning. All right, so how would you festoon this? So I'm going to use the inflate tool. So this is one of the things not quite as ideal doing dental type work in Meshmixer, because you don't necessarily have really easy to use add remove tools, things like that you would have in ExoCAD, Blue Sky Plan, 3Shape, all those. But you know what? It's free, so no need to complain about something that's free. So I'm just festooning here. I don't have to, like with a conventional denture tooth, I worry a lot more about getting lots of that tooth covered so that it doesn't end up popping out or something. But here, you're going to print this tooth in a very similar resin to the base itself. So those things bond really well, and I don't get too worried about trying to make the necks of the teeth be completely covered. There's a lot of ways that we can remedy that, and the bonding is just better. Okay, so now I've done the buccal there. Now I'm going to go to lingual. I do want to get up into these interproximals though. That's the area that's going to be primarily missed in this process as I've shown it. So let's cover some of the neck of the tooth, but particularly get up into that interproximal. Come on. Sometimes if you zoom in too far, it can be a little difficult to get back out, get your view set again. So increasing the thickness here. I just need to finish the lingual, these premolars. And then because that tool, I use it too strong, I end up having to come back and just briefly hit it with the shrink smooth tool. Okay, and want this nice and smooth, and of course I could smooth it after the fact, after printing, but why would I want to add any extra steps if I can do that now? Okay, and smooth that up. So that's looking pretty good. I'm pretty happy overall with the festooning of this now. So at this point, now I could go ahead and join them. Now I am thinking that clasp is going to probably be very, very rigid unless I shrink that back a little. So let me try shrinking that just a bit. I can see here how I'm altering the thickness as I do that. And I'm just eyeballing it. That's all I'm doing. Okay, I like that better. There we go. Now, I've done these too before where I would maybe offset clasps first. That way I can really easily control a consistent thickness with those. But honestly, you're just as well to do them thick like we did to 2 millimeters and then just come back and grind them down again because this material does adjust so easily. Okay, so just one more look over to make sure I'm not seeing any excessively rough contours, things that are going to cause problems for the patient. And I'm not really seeing that. So at this point, I'm ready to join the base. And we're just a couple of steps from being done. So there's the internal of the base. Hide the teeth. So these are the two I need to join. I'm going to control select both of them, combine, and now I need to use the select tool and get a very small spot size. Now you can select just the border. Some people struggle with that, like, just click right on the blue line. If you need to, turn the wireframe on by hitting W. And really what your goal is, if I clear this, your goal is to just click on one of these outermost triangles that's touching the border. So if I do that, you see it selected all. Now let's do the same from the internal. So I've got all the borders selected. Not a bad idea to just one more time hit O and then B. So optimize boundary and smooth boundary. And now I've got a nice smooth continuous boundary selected. And then you could either go to edit and join, or the hotkey is J. So I'm going to hit J. And this tool is useful because it's just going to stretch out and try to find the closest border to it of the other mesh you have selected, which in our case is exactly what we want. We don't want it, doing some crazy contour. You see it just reached directly across the gap and joined that with the continuous boundary. So let's accept it. Now we have a continuous boundary. All of these tools, right after you use them, that surface is still going to be selected. So you could do maybe some other stuff while it's selected, like maybe you wanted to smooth the boundary, not like the triangles, but actually like smooth the mesh itself. So I've selected both of those clasps because I want to smooth off their contour. There we go. And then go to deform and smooth. Doesn't have a huge effect, but it does smooth things out just a little bit. So I've accepted that now. Okay, so think about, again, in terms of a flexible partial, what's the one thing that we're missing now? You could print this base and it should be ready to go, but you don't have sockets into which you can put these teeth. So we need to create those. All right, so multiple ways you can do this. I prefer to go ahead and use the solid one. So these were the ones we made solid earlier. Yes. I'm going to go ahead and duplicate those because I always want a baseline that I can come back to. And ultimately what we're going to do is subtract a set of teeth from this base. So if I subtract them and I've not exported that and saved them somewhere, then I've lost them. So not a bad idea just to duplicate it. Now you got one file in the background that you can just keep. Okay, so again, think of it in terms of a denture that you've done digitally. We could just straight up do Boolean subtraction of the teeth from this. However, if you do that, you're going to have a dead zero offset. There's no space for cement. It's going to bind up, all of those issues. So we've done it a bunch of times already in this demo. What would be better is to go ahead and just take all of these surfaces of the teeth, and I'm just going to hit Control A, selects everything, and I'm thinking about how much of a cement spacer do I want between teeth and base. The denture module, I think, defaults to 0.2 or 0.3. Let's just, for the heck of it, go 0.25. We'll split the difference. Well, that took a minute to think, and I don't want to wait again. It's at 0.28, so I'm just going to roll with that. So let's accept it. Now, I see this throw people for a loop too. Right now, all of this is selected. You would be wise right now before you do anything else while it's still selected to hit Y, which is separate. Why is that? Because when we offset it, many times we forget that what is it that we offset? Well, it's the original teeth, and they're still underlying here, okay? So if you tried to Boolean both of these models combined together, it's just not going to work. Just take my word for it. So we actually just want to Boolean the offset surface. That's what we have here. Sometimes in doing that Boolean expansion, or I'm sorry, the offsetting, you might potentially create some areas of mesh that cross over one another. So it's not a terrible idea once you've offset that to go ahead and just make solid again, which is going to take care of any triangles crossing over one another, things like that. So I'm going to increase accuracy halfway on the mesh density, update. All right, now those are solid. So this is what I can now subtract from my finalized denture base. If I can find it, there we go. So have both your models visible, select the base first because you're subtracting from it. And what is it we're subtracting? We're subtracting these teeth that I offset by 0.28. When I double click or when I control select multiple objects, you'll see this pop up. If it doesn't, while these are both selected, come down here and hit edit, and that will bring this up. And now just hit Boolean difference. And now we have the bases. Usually it won't matter too much, but I would suggest getting the habit of unchecking auto reduce result. It won't affect this one, but again, until I can get my Meshmixer course finished, just take my word on it. That will help you. So there's your base. Always run your analysis inspector. You're going to have some little errors, just fill them in. Done. And now I can export this, and I'm going to call this final flex base mandible. And then remember, these are those teeth. So these are the original teeth prior to any of that offsetting or anything like that. So just to give you an appreciation of the spacer between them, I'm going to just take this plane cut tool right now and just directly go across that. What you should see it's so small it's hard to see, but there is now a spacer between teeth and this base that allows us to put those teeth in. I wonder if it would show better if I would do. Yeah, now you can start seeing it a little better. You see the offset spacer between these, so that just gives us somewhere that we can actually put some resin and then seat these things passively. All right. Only thing I'm not loving is that. So I'm going to fix that. This is a bonus for you. So I'm going to take that. I'm just selecting that part, F for erase and fill, and I'm going to drag this bulge slider back and make that where it's somewhat concave. Okay. And then the base, I want to get rid of that perforation through it. So how could I do that? A few different ways you could. I'm going to take my select tool and I'm just going to grab the edges of this hole. Okay, very small area, B for smooth, delete it. Now, when I run an erase and fill, what it's going to fill across is this hole. Okay, so I could either do analysis, inspector, and just fill that, and you see it fills across. Or alternatively, if you've still got this thing open, you could just select the boundary, F for erase and fill, and now you've got a little more control over what's called the bulge, like how concave or convex does it need to be, okay? And maybe that affects fit a tiny bit. That's so small that I'll just pre-adjust that tooth in that position. Or if I'm worried about it, I'll just, again, go ahead and take these teeth, and if that area is of concern, then I'll just take this, maybe I grab a little bigger part. So if I hold shift and greater than arrow, that is expand ring, see the greater than. So now I've expanded a bigger area and maybe I subtract a little bit more, F, and then drag back the bulge. This is not in an area that's showing anything, so I don't care if it's deficient, it's just gonna have a little more resin occupying that space when these get bonded together. Okay. So that is the entire design for this partial. At this point, I can now grab whatever resin I intend to print these in and go ahead and print those. And I would do the teeth in some kind of a permanent, semi-permanent crown and bridge material. The base you could do in either denture base, you could do it in flexible denture base, which is a new material I'm playing with. You could do it even in something like indirect bonding tray, a clear resin. You got a lot of options is the point for this. Maybe soft splint. All of those would work. And then your color would shine through of the natural gingiva. So anyway, that was kind of the overall process of me making this flexible partial. You can do the same type of approach for any kind of partial, single tooth flipper, whatever it is. This is an approach that works really well. So I hope you found that helpful.